Okay, so we have this function. In part A, we're asked to use this function to find the local linearization at a equals 7. And then part B, we have to approximate the square root of 8.8. So let's point out really quickly that part A is going to be an equation. That's what our solution is going to be. Part B, our answer is going to be a number. Okay, so we're going to have variables in part A. We're not going to have any variables left over in part B, okay? So, y is approximately equal to the local linearization. I'm going to use t because that's what the function has. And that's equal to f prime of a times x minus a plus f of a. Okay, so this is our a value. And here's our function. So we need a couple things. We need this guy, we need this guy, and then eventually we need to plug in this guy for a. Nothing to plug in for x because part A is just an equation. So we first need the derivative. So we have f of t is equal to the square root of t plus 2. Let's go ahead and write that as t plus 2 to the 1/2 power, because now its derivative is just going to be equal to 1/2 times t plus 2 to the negative 1/2 using chain rule. We multiply by the derivative of the inside, but the derivative of the inside is 1. So we can just write that there, but it doesn't change anything. So now we need to evaluate these two functions at a so that we can have our numerical values for the two underlined parts in red. So f of 7 is going to be equal to 7 plus 2, square root of that, which is square root of 9, which is 3. F prime of 7, here we have 1/2 times 7 plus 2 to the negative 1/2. So that's the same thing as saying 1/2 times 1/3, because we know that 7 plus 2 is 9, square root of that is 3, but because it's a negative exponent, we bring it down to the denominator. So we get 1/6. Okay, now we just put this all together. So the local linearization is going to be f prime of a, which is this guy. So we have 1/6 times x minus a is 7. And then plus f of a, which is 3. So plus 3. So that is our solution for part A. You did not have to simplify this like I did, but you can, because we're going to have to use this down here to get an answer. So we have to use what we got in part A to do part B. So the only thing we need to do is plug in for x. So we need to figure out what x value to plug in. This is a y value, okay? But there is some t value. Sorry, I should have wrote t here, my bad. T, okay. There's some t value that gives me the square root of 8.8. Well, f of t is the square root of t plus 2. So that means f of 6.8 is equal to the square root of 8.8. I got that because if we set these two equal, right? If I square both sides, I'm left with 8.8 equals t plus 2. If we subtract the 2 over, that gives me t is equal to 6.8. Okay? So we have our t value. So now we just plug in t for this piece, and then we're done. So the local linearization at 6.8, again, that's our t value, is 1/6 times 6.8 minus 7 plus 3. Again, you don't have to simplify, but we might as well because these numbers aren't so bad. This gives me 1/6 times negative 0.2 plus 3. This is the same thing as 1/6 times -2/10. Hopefully that's not too surprising. Plus 3. Try not to make any illegal algebra moves if you're going to simplify. The person grading might not be forgiving. We can simplify the 2 and the 6 to give me 1 and 3. So we have, let's see, -1/30 plus 3 is our solution for part B.